Okay, just like in 7.3, we're going to keep talking about sampling distributions in 7.4. The big difference in 7.4 is that we're talking about proportions instead of means. So what we want to do is make sure we understand what a proportion is before we go into and this any further. So a proportion is a percentage or fraction of the population that we view as successes. Oops. So a proportion is always used in an example where there are two um, answers only to the question. It's like a yes or no question. So the proportion that we view are basically the people who answered yes to the question. Okay. So um, what we want to do is make sure that we're using the correct notation. So let's make sure we not note the notation, and then we'll be able to keep talking about how we make a sampling distribution on a percentage instead of a sampling distribution on a mean. So the notation that we want to think about is similar to that from chapter 6. So I don't want people to get overwhelmed that we're doing things that are similar to chapter 6. But the notation we use here is lowercase letter p, and that represents the population proportion. So this is the proportion of people who we deem successes. And then we also talk about the letter n, which represents the sample size. So we have the population proportion and we have the sample size that we need in order to do the work to find the sampling distribution for a proportion. Now, a sampling distribution for a proportion, make sure I spell it right. This is a normal model. So just to remind us of what that means, right? That means it's unimodal and symmetric and centered at the population proportion. So the center of the normal model is actually the population proportion P. So for us to draw that out, I want to make sure that we understand what I'm talking about. So we have, that's terrible, but we have like a bell shape, and in the middle of that bell shape is the population proportion sitting where the mean normally sits. So that is what a sampling distribution for proportions would look like. That would be sitting at the center. So the way that we described that in 7.3, we used capital letter N, and then the first value we stated was the mean, and the second value we put in the parentheses was the standard deviation. So the capital N just means that this is a normal model, right? And then the very first value we put in those parentheses represents the mean, and the second value we put in the parentheses represents the standard deviation, just like in section 7.3. So we know that that's unimodal and symmetric on the left, so it is a normal model. And instead of a mean like x bar or mu in the center, we put p. So that is what we're going to put in the place of the mean. And then we need to insert the formula for the standard deviation. So we need to be able to compute the standard deviation. And that is always under a square root, and it would, or involves a square root, excuse me. And it would look like this: p times 1 minus p all over n. So the whole thing is underneath the square root. And that equation is used to compute the standard deviation for the sampling distribution. So this is the mean. Whoop, I dropped my iPad. I'm sorry, guys. This is the mean for the sampling distribution. And this is the standard deviation for the sampling distribution. And that's just for proportions. So what we do essentially for each example, we have kind of a trajectory we have to take. So let me make sure I write out what the steps would look like. Okay. So for questions involving sampling distributions on proportions, there's a very like standard trajectory that we use for every example that we always do. So the first step is that we would compute the mean and standard deviation for the proportion. So that would be creating this model, a normal model, where the proportion is the mean and we find the standard deviation. So that's our first step, is that we compute the mean and the standard deviation first. Then our second step is always to use, I don't know why I put it in caps, normal CDF to answer whatever the follow-up question is. Okay. So there's always two parts to this process. First, we're going to find the mean and standard deviation. And then after we compute the mean and standard deviation, we will use normal CDF to compute the answer to the actual question we're being asked. So what I'm going to do is follow this up with an example video of me solving one of the problems in the packet so that we feel good about this. So look forward to that next. Okay. Let me know if you have any questions.